explain to you exactly what it does and how it does it. But to do that, I need to explain the whole code breaking process so that you understand exactly how the bomb fits in.
Your group's growing big time.
Now, it's a very complex process, so I won't promise to. I'll promise to do it in very simple terms. Enigma machine. Now, we're only using the middle bank for demonstration purposes. Normally, we have drums on all three banks. You have 36 Enigmas all working together. Now, you can see the top drums are going round constantly. You can also see that as they go round, the next row moves on one letter at a time. Every 30 seconds or so, that second row will have gone all the way round, and that's when the bottom row moves on one letter.
Keep watching.
That row only moves one letter about every half minute.
Now.
There you go, just to prove it does move. Our German Enigma operator is pressing the W and the Y lights up. He then presses the E and the A lights up and so on. So we're going to allocate each one of these pairs of letters to one of these Enigmas to search for. Take the first pair, W to Y, and our first Enigma. Now around the back we've got lots of these leads hanging down. Spaghetti. Right, now the sockets they go into, many of them are labelled A to Z, and many others are linked to the input and output of the various Enigmas. So our first lead, one end is going into the socket labelled W, the other end is going to the input of an Enigma. Another lead will then go from the output of that Enigma to the letter Y. So straight away that Enigma is searching for that pair of letters, and all the other ones, they're all wired up to search for the other pairs of letters in that crib. Now sticking with this one here, while it's scrolling through those 17,500 positions and checking every one, every time those three drums get to a position where the W coming in gets encoded to a Y, just as if you press the W on the Enigma and the Y lights up with the rotors in the right position, every time that happens, that Enigma will break its circuit and try to stop the machine. Now I'm sure you can appreciate that the 17,500 positions it's looking at, it's going to find that pair of letters a few hundred times. But the machine doesn't stop a few hundred times because all the other Enigmas are looking for their pairs of letters in parallel. So what that means is the only time the machine's going to stop is when every one of them finds its own pair of letters all exactly at the same time, they all break the circuit at the same time, and that briefly cuts the power and forces the machine to stop. Now when it stops, we've got three gold and black drums on the end there. And against the pointers we get three letters. That's the first piece of information we get from the machine. There's no printout to write that down. Now also when it stops, round at the side is a little window, and that will give us another letter and some other bits of information as well. And eventually all that information is going back to the code room. But before that happens, the bomb is going to stop several times, probably about half a dozen or so times on average. If you're lucky, it's going to be slightly less. If you're not so lucky, it's going to be a lot more. But around about half a dozen. The problem is, each time it stops, you get a different answer. And only one of those answers can be the right one. So every stop has to be checked. Now, when the bomb stops the first time, one of the RENs operators will take this information and she'll put it into a little machine that will be standing here called a checking machine. Our two machines are behind us. Now that's a very powerful machine. It can actually tell us whether or not that was a correct stop. If it says it wasn't, then she'll come back and wait for the machine to stop again, put a different set of letters in, and hopefully eventually one of those stops will be confirmed as the right one. Now when we get to that stage, we've got a very small part of those settings of the day. We call it the key of the day. Not all of it anywhere near, but it's just enough to go back to the code room. Now the code breakers are going to sit in a very quiet environment and using logic, process of elimination and a certain amount of mathematics, they can hopefully come up with the key of the day. It can take quite some time. It can be very variable, anything from half an hour to several hours. It's also something we do regularly here. We are code breaking all the time.
Just for fun,
Just
they
for
tell
fun,
us.
yeah. But it seems a bit like the war's never going to end. Now that
Shall I say
process,
especially on Saturday
Saturday
afternoons?
afternoons, yeah. That process is very, very complex. I'm not going to attempt to explain it to you. To break it right down to the basics, if you can cast your mind back to school days when you did algebra, does anybody remember something called simultaneous equations? Oh, one or two, yeah, that's good.
You're allowed to groan.
Probably forgotten how to do it, but even so, you remember the name anyway. Well, that's the sort of best way to explain it. You've got a small amount of information and lots of unknowns. All those X's and Y's, if you remember. So just imagine we've got lots of mathematicians using algebra to solve a whole range of three-dimensional cryptic crossword puzzles. You've got an idea of the sort of level we're at. So after a certain length of time, hopefully they've got the key of the day. It'll be a very simple matter to set up an Enigma machine and decode all the rest of the messages from that network the rest of that 24-hour period. Bearing in mind, of course, they change the code at midnight and we start every morning with a blank sheet of paper. Now there is one small problem. The Enigma machine's a German machine. We have acquired a few of them, but we really needed hundreds and hundreds of them to decode the thousands of messages every day. So what we did, we turned our attention to our British cipher machine. That's the one in the far corner there. That's called Typex. That's what we sent our secret messages to each other with. Now, it was based on the same principle as Enigma. Started developing that in the sort of early to mid-30s, prior to World War II. But we made it very much more complex, so we know for a fact the Germans never cracked that. Now, I said it was based on the same principle as Enigma. We actually infringed their copyright, but we weren't exactly going to ask their permission at the time. And after 80 odd years, I think we got away with it. So. Now, it was an easy matter to convert many of those to work just like Enigmas. That one has been converted and we use it quite regularly. So we could put in the key of the day, type all this gobbledygook as it came in, get plain German, plain Italian, whatever. That would go to our army of translators here who would translate everything into English. And finally our intelligence people would decide how important the message was, whether it had to go to the Admiralty, the War Office, the Air Ministry, or very often Churchill himself sometimes, and hopefully help to shorten the war and save lives. So that's the code breaking process in a nutshell. I know it's a rather large nut, about as simple as I can do it. Before I shut up, I will bring you right up to date. The Bombe team here, we have a very special relationship with GCHQ. Unfortunately, that means every now and again they decide to take their Enigma machine to a science fair somewhere, and at 9 o'clock that morning they will actually send us an encoded message and challenge us to break it, using this being the only working bomb in the world. We have done 17 challenges up to now, and the score is 17-0 to us. Really just a case of how long it takes us. We boasting really now, but the longest we ever took was about 5 hours, which in itself wasn't that bad. The record to date is 1 hour and 20 minutes, which is really going some. That's right from beginning to end. On average, it's about 2 to 3 hours, which is quite comparable with the Luftwaffe messages during the war. Well, thanks for listening, ladies and gents. I hope I haven't bored you too much. We'll switch the machine on again, so you can pop round the back. Helen will give you a few facts and figures, a bit of history. If you've got any questions of any sort, please don't be afraid to ask.
Thank you so much.
Thank you.